All right, so in this video, we're going to go over composition of functions, okay? Composition of functions or composite functions, all right? So we've got f of x equal to x squared. We've got g of x equal to x minus 3, okay? So we want to find the composite functions f of g of f of f, and g of g, okay? And then find their domains. After we do that, we're going to evaluate each of those composite functions for a set value of x, okay? So actually, I'm going to start with the domains, okay? Both of these functions have a domain of all real numbers, okay? Or from negative infinity to positive infinity, all right? So because that's the case, the composite functions are also going to be all real numbers, okay? So these composite functions will be defined for all numbers of x, okay? All right, so f of g, we're going to find f of g first. So f of g of x is the same thing, like writing it this way and writing it this way. They mean the same thing. The notation's a little different, but they mean exactly the same thing. Okay, what this means is we're going to take the g of x function and substitute it into the function f, okay? So I'm going to find f of x minus 3 because g of x is x minus 3. So all I've done here is I've substituted x minus 3 in for g of x, okay? Now I'm going to substitute x minus 3 into the given function of f, okay? So if I replace x with this x minus 3, then I get x minus 3 to the second power, okay? There's no reason to multiply that out. We'll leave it in factored form like that. It's easier to use like this anyway, okay? So that's f of g, all right? Next, let's find g of f. So again, notation, notice it's a little different, but it means the same thing. G of f just means we're going to have function g, and we're going to evaluate it for whatever f of x is, okay? Well, f of x is x squared. So I'm going to find g of x squared. So I'm going to replace x in function g here with that x squared value. So when I do that, I get x squared minus 3. I replaced x with x squared, so x squared minus 3. Nothing I could do there. I can't factor that even if I wanted to. All right. Let's find f of f. Okay, so f of f can be written either of these two ways. Okay, remember f of x is equal to x squared. So I'm going to find f of x squared. Okay, so I'm going to replace this x right here with x squared. So I get x squared to the second power. I use my rules of exponents here, my power raised to a power. So I'm going to multiply those exponents, and I get x to the fourth. So f of f is equal to x to the fourth. And then finally, we're going to find g of g. Okay, so the notation you see there. All right, I'm going to find g of x minus 3. So I'm going to replace this x with x minus 3. And I get x minus 3 minus 3, which simplifies to x minus 6. Okay, so that's the 4 different composite functions that you're most likely to see. Now, a function can be named anything. It doesn't have to be f or g, okay? But these are the basic rules for how you find composite functions, okay? Now, let's evaluate each of these let's evaluate f of g for the value at 5, okay? So what we're going to do is we're going to replace x here with that value 5, okay? And when I do that, I get 5 minus 3 squared, which is 2 squared, which is 4. Okay, so f of g of 5 is equal to 4. Okay? Let's evaluate g of f of 7. So I'm going to take this composite function here. I'm going to replace x with that value 7. So that gives me, this is f of f, excuse me. Let's go on down to this one. F of f, I'm going to replace x here with 3. So I've got 3 to the 4th power, which is 81. So that was f of f, excuse me. Now let's do g of f. All right, g of f, I'm going to replace x here with 7. So that gives me 7 squared minus 3. Order of operations, 49 minus 3, which gives me 46. And then finally, let's do g of g here. I'm going to do that for the value 1. So g of 1. Okay, I'm going to replace x with 1. That gives me 1 minus 6, which is negative 5. Okay, so that's composite functions. How you find the composite functions, determining the domain. In the next video, we'll go over one where the domain's a little more difficult to find, okay? And then the last thing we did was evaluate the composite functions at certain values of x.